Hello everyone, this is Mrs. Herrera with 422's Classwork Sketching Polynomials. This is 5.2.3 on our Google Classroom and refers to page 253, 254. So, sorry this took a little while, but I'm trying to figure out how much to give you in a little bite, if you will, so that you're not overwhelmed. But there's a lot of information about sketching polynomials. So let's take a look at an example. If f of x equals x times x plus 2 times x minus 3, there are three factors. The sign of the function values tells you if the graph is above or below the x-axis on a particular interval. You can find the sign of the function values by determining the sign of each factor and understanding what the sign of the product of those factors is. Is it negative? Then it's going to be below the x-axis. If it's positive, it's going to be above. All right, so what are some things we need to remember and we need to learn about polynomials? If the degree is even or odd, we need to know that because that's going to impact the sketch of our polynomial. If the a value, which is your leading term, is positive or negative, that's also going to impact the picture of my graph of the polynomial. So here's what a regular polynomial is going to look like. You have p of x, a is my leading coefficient, and then I have a set of factors. So for f of x equals x times x plus 2 times x minus 3, let's take a look at this. So my degree, my n is 3. Why? Because x to the first times x to the first times x to the first is going to give me x to the third power. So I know the degree is 3. The leading coefficient right now, x, is just 1. It's 1x, so it's positive. So what is that going to do for us as far as graphing our polynomial? Let's take a look at that. The x-intercepts occur when x equals 0, because remember the zero product property says if you have factors multiplied together and you yield 0, one of these factors has to be 0. Like 2 times 0 would equal 0. Again, one of these has to be 0. So we're going to set each of them equal to 0. So if x equals 0, then 0 is one of our intercepts. If I set this factor x plus 2 equal to 0 and I solve for x, then one of my intercepts is x minus 2. My third intercept, x minus 3, equals 0. And then if I add 3 to both sides, I find the third intercept is 3. And here's a rough sketch of what this looks like. -2, 0, and positive 3 are the intercepts. Okay. There's going to be 4 intervals for this picture. And when do they occur? They occur when my graph is less than -2. And again, how do I know that? That's one of my intervals. So if I go to the left of that, that would be the values smaller than -2. Well, where does this one come from? My next larger x-intercept is 0. So I have to investigate and explore what's going to happen to my function between -2 and 0. And then the last x-intercept is 3. And so I need to know what's going on between 0 and 3. And lastly, when x is greater than 4, what's going to happen? Okay. Shouldn't be 4. That should be 3. Sorry, guys. It's been a long day. That should be 3. Let's fix that. All right, while I fix that, let's continue on because I try to keep these greater than 3. Sorry, sometimes it happens. A lot of phone calls. All right, interval. The first one we're going to investigate is x is less than 2, then x is between 0 and -2, between 0 and 3, and x is greater than 3. Now again, this is not something you need to complete. This is just something that I want you to understand. So the sign of the constant is positive. Why? Because we have x out front here and x is positive. There's no negative sign in front of me. So all of those are plus. Why does this one change, the sign of x? Well, for x is less than -2, that would be x is -3, -4, -5, so the sign is going to be negative. What about when x is between 0 and -2? That's like -1, -1.5, -0.5, and therefore the y value will be negative when x is between those values. And again, I'm missing a sign. There we go. Between 0 and 3, x is +1, +2, +3. That gives me that positive sign for the function. And then when x is greater than 3, 3, 4, 5, 6, 7, that's positive. What would be the sign of x plus 2? Now remember, we're substituting in for the x. So if x is less than -2, let's pick a number, -3. -3 plus 2 yields -1. It's negative. If I go to the next interval between -2 and 0, what will be the value of x plus 2? Well, let's say it's -1, and we come over here, -1 plus 2 is +1. Okay, so again, I don't have to go over all those. We're pressed for some time, but what you're doing is you're substituting values for x, and you're determining what will be the sign of the result. So now, what is this? This is the sign of the entire function, or f of x we also say is y. So what will be the value of the whole function? Is y going to be negative below the x-axis or positive above the x-axis, and where does that happen? And again, you would substitute in your x values. We also can just go take a quick peek at my graph up here. So when x is less than -2, you can see that the function is below the x-axis, therefore the y values are negative. Between -2 and 0, all of my values of y are above the x-axis, and therefore if you look down here, that's what that positive represents. When we look at between 0 and 3, all of my y values, the function is negative below the x-axis. All my y coordinates are negative between 0 and 3. And lastly, when I go larger than 3, all of my y values will be positive because they are above the x-axis. Okay, ready? Switch. Okay, here's where you have to fill in. So that was just sort of notes, if you will. So here's some things I need you to remember. Odd functions, opposite directions. Even functions, equal directions. So if it's an odd function, I have two quick pictures here for you. Odd functions, opposite. So if x is to the 3rd power or the 5th power or to the 7th power, 9th, 11th, any odd number, you're going to find that they go in opposite directions. My function, as x gets smaller and smaller, y approaches positive infinity from one side, and then from the other side, y approaches negative infinity. This one is slightly different, but again, odd means opposite. As we get smaller and smaller for x, as x approaches negative infinity, y approaches negative infinity. On the other end, as x gets larger and larger, so does y. So how do I know if it's going to be the red one or the blue one? Do I know if it goes up or if it starts down? And it's very easy to tell. If the leading coefficient is negative, negative x times blah, 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 it's going to end up down. If it starts off with positive x, blah, 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 x to the 5th, x to the 7th, it's going to go up. And here's how you remember this. Negative people look down at the ground, right? Anyone who's negative is kind of looking down at the ground, whereas when you're positive, you're reaching for the stars, and so you're always reaching up. Again, negative polynomials, odd negative polynomials start up and down. If they're positive, odd polynomials, they start off down and go up. Again, positive people look to the stars, and negative people kind of look at the feet, and So, odd, opposite, even, equal directions. Let's take a look at even functions. So our even functions, they can flatten out in the middle, or they can have this sort of W shape. It doesn't really matter what's going on in the middle, but what has to happen is both of my end behaviors are going to be the same. So in this case, they're both approaching positive infinity. I didn't write that in there, but you guys know that. They're both approaching positive infinity, whereas this one, they're both approaching negative infinity. How do I know whether they're both up or both down? It's that leading coefficient again. So if my leading coefficient is positive, point towards the stars. Negative people look at their feet. They're always looking down. And so that's why the negative one has both of them facing down. Odd degree functions cross the x-axis. Oh, I apologize. Odd degree factors, not functions, odd degree factors. So now let's look at that x plus 2 squared, or x minus 3, x plus 5 to the 7th power. So we're actually going to look at the individual factors, and that's going to give us an indication of what our expectation is in the graph of the picture. We're now on page 254. So again, let's take a look at this. This is x minus 4. There is no exponent, so I know it's to the first power. That's going to cross, it's going to cross the x-axis at 4. This one has an exponent of a 1. This one has an exponent, so it's going to cross in these places. If this was x minus 1 squared, think of a polynomial. It's going to touch down. That parabola is going to touch and be tangent to the x-axis, but it's not going to cross it. All right, so let's just remember that. And next we're going to identify end behavior. As x gets bigger and bigger, what happens to my function? The function is going to approach negative infinity. As x approaches negative infinity, the function is going to approach negative infinity. How do I know that? Take a look, if you will, please, at the different x-intercepts. We have x equals 4 because you're going to set this factor equal to 0, and we're going to solve it. So x equals 4, you guys know how to do that. X minus 1, set them both equal to 0. And so when x is 1, it's going to cross. And for this one, x plus 1 becomes x is minus 1 for the actual x-intercept. And x plus 2, you subtract 2 from both sides, and you get an intercept of negative 2. Okay? All right. So here we go. I just want to point out again here, how do I know that they're both in the same direction? I don't think I explained that thoroughly. X to the first times x to the first is x to the second, x to the third, x to the fourth. So my degree is 4. So remember, if the degree is an even number, they're either both going up or they're both going down, both of my end behaviors. How do I know which one it is? They're both going down because that little thing right there. All right, my leading coefficient is negative, and so that's why those are both negative. All right, let me wrap this up because I don't like to go more than 15 minutes for the direct instruction component. So here we go. Let's take a look at the intervals quickly. How do I know how to set this up? I look for my absolute smallest of the x-intercepts, which is negative 2. So I want to look at all the numbers that are below negative 2. And then I say, what's the next number next to that? Negative 1. So I need to investigate the interval between negative 2 and negative 1. My next higher intercept is 1, and so I want to go between negative 1 and 1, and between 1 and 4. And lastly, what happens to my function when x is bigger than 4? Now, the sign constant is always going to be negative because of that right there. That's your leading coefficient. How about these? How do these get filled out? Again, I would like you to try them and then check it against mine to make sure that you get the same value. Where do they come from? Well, if you look at this, when x minus 4, look at that factor, and you say, well, when is x less than negative 2, it could be negative 3. So if I do negative 3 minus 4, I get negative 7. So the sign of that is negative. And the same thing here. Between negative 1 and negative 2, let's just say negative 1.5. So if I go back here, negative 1.5 minus 4 is also negative. Why does it switch to positive over here? Because when x is greater than 4, let's just try a number, substitute. How about 5? So 5 minus 4 is positive 1. And so that's where those come from. And again, take a look at it. I don't want to go over my 15-minute allocated time. So plug those in, substitute, and you'll see where those signs come from. But what I'm really concerned about is, what does the function look like? Between which values is it above? Is y positive? Is my function above the x-axis or below? So Ava, if you could just, actually let me do the bottom so they can see that. The function is going to wind up being above the x-axis between negative 2 and negative 1, and also between positive 1 and positive 4. Where will the function be below the x-axis? And again, I'm using some shortcut notation. Where will it be below the x-axis? When x is less than -2. Also, that u is means in union with. That's just a math notation. So we have x between -1 and +1 in union also with when x is greater than 4. You're going to lift it up, or you're going to hold it up so I can see. Oh, you stink. Okay, this is my, sorry guys, this is my Desmos graph that I've already put in for us. There's the negative x minus 4, x minus 1, x plus 1, x plus 2. Those are the various factors, and this is the function that it yields. And Ava, just hold it right in front of me so I can do this quickly. I'm out of time. So if we look at this above, slightly above. Okay, so where again is the function itself, negative and positive? After -2, which is over here, anything after -2, it's negative. Between -2 and -1, I apologize, the value of my function is positive. Between 1 and -1 and +1, it is below the x-axis. Between 1 and 4, it is a positive. And then everything after 4, the value of my function is negative. All right, guys, I went a little over. Hope this helps you. If you need, reach out to me. Have a very safe, healthy day. Please stay inside. Again, message me if I can help you in any way. If not, check your work, make corrections. Please submit all your work into Google Classroom. Have a great day.